Hello everyone, my name is Anton Glinkin. I'm Senior Application Engineer at CDT, and today I will tell you something about PDB, Parts Database. We will be talking about what is a PDB itself, what makes up a PDB, are there any differences, and what is the definition of fractured symbol, multiple cells. When you want or when you don't want to use PDB properties, talk about some PDB errors and how packager in your layout, in your schematic editor is working. PDB is one of three main elements of central library. It establishes connection between symbol definition that contain pins with pin names and cell definition, which includes pins with pin numbers. So basically we have PDB, part database, associated part number with it, and prefix. And your symbol representative gate will be mapped into your cell, and you'll have multiple numbers of these gates added into this cell. And then you can define swappability of those gates in cell. For example, on the screen you can see that there are some IC component that can be basically shown as only one gate multiplied 4 times. Next, you would want to define swappability of pins within one of these gates. And finally, what we can do is to add part properties to each PDB entry. Let me show you some demo. Basically, this is our part editor. In Expedition and Path Professional, it's the same. Let's create some component that can be represented in different ways. Here is our component symbol. You can see it on screen. And now I want to start with creating of the full representation of this symbol, all in one. Using the regular expressions in import option, I'm finding it. And what I want to do is I want to disable this option, create new gate information. Now in logical tab, we can see all pins of these components. And if you remember the symbol of it, it contains basically 4 sets of 2 pins and 1 common pin for each of these 4. We create new gate information, 8 gates and 3 slots in each of them. Now we can use property to assign how we will be filtering our pins. It will be pin type. I want to set, according to the datasheet of this component, values of these pins, input, restate, and input, and assign all inputs, all pins named I, to the according slots. I use pass across functionality just to move them from the left side of your screen to the right side. Same for output. And common pin. For common pin, we need to remember that it's 1 for each 4 of that. So I will basically copy the name of it to the according slot. As you can see, OE1 pin goes to the pins from 0 to 3, and OE comes for pins starting from 4 to 7. Basically, we created the definition of the full symbol. Now, what I want to do next, I want to create half gate. Physical tab, right. In physical tab, we assign the physical pins, pins of cell footprint according to the symbol pins. All this information about mapping will be stored in PDB. So that's why you should remember that there are some features that can be used to make your life easier, and you will see why. I'm closing pin mapping and reopening it again just to add new symbol. This will be half symbol. We will not be creating new gate information as well. So I just hit OK. And as you can see, we now have only half of pins, because in symbol that we just imported, there are only 9 pins, 4 inputs, 4 outputs, and 1 common. I'm assigning it in the same manner as I did previously. Copying the common pin to all 4. And after that, I basically need just to click OK, and system will automatically recognize that it is half symbol. I'm restarting it. And as you can see, all pins was assigned to that symbol. In supply and NC tab, you can assign global supply name to the pins that you choose. This can be changed later. I will show you how. And if you have some not connected or not routable pins, you should put it here. Last thing to show is I'm adding the new gate, new symbol for singular slot, only 3 pins. I will not be adding new gate information as well. Switching to that symbol, and I need to assign this input, output, and common pin to the slot 1. Just 1, 2, and 3. I'm OK. Open it one more time, and I can see that all was assigned correctly. So now your designer or your layout engineer, it depends on who doing this job in your company, can choose which way, which kind of representation will be more easy to use for you. Let me show you what I mean. Here we have some library. In part editor, what you can see here. First of all, this is partition list. You can create and modify partitions using this button. I want to switch to this exact partition. There are 3 columns: part number, part name, and part label. Remember one simple thing: part number always should be unique. Part name and part label, you can name them as you want, but this thing is always should be unique. This radio button, you can switch it to define which symbol will be used by default in schematic. Go down, we can see component properties. Right? First of them is component type. You can assign more accurate type on your selection, and you can also add some new component properties. It depends how you will be managing your library. There are a couple things that you should be thinking of. I was talking about that in my previous webinar about central library. But basically, you can add just, for example, I want to add manufacturer part number and put something here. window for short description, it's quadruple 2-input AND gate, and reference designator prefix. This is pin mapping dialog that we just saw on your screen. There are 3 tabs: logical, which is basically represent the symbol pins; physical, representing the cell pin; and supply and C for additional options for non-signal, for not connected. Gate is basically a representation of your symbol, amount of slots, how many times it was repeated. You can set the swappability of pins and gates between each other using commands here. As well as if you want, of course, you may have multiple symbols, because, for example, if you're using FPGA, it's just physically not possible create one full symbol for FPGA because of huge amount of pins in that symbol. So it will be logically to use to create fractured symbols. For example, split these FPGA into banks, or split power pins in the separate symbol, and so on. And if your component have a lot of doubling pins, like I was showing, it may be also related to the schematic that you're creating, and it just will not be accurate, will not be nice to have only one full symbol because of huge amount of nets that you need to connect to this symbol. So you can just split it into couple symbols and put them onto different places of your schematic. As well as you can have multiple symbols, you can also have multiple cells. But there are a couple rules. Each part definition must have at least a top cell, and if there is only top cell, it will be used for all sides, both sides. Bottom cell can be defined if a different cell is needed to have different abstract, outline, etc. And if you push this bottom cell from top to bottom, it will be used instead of top cell. There are also such things as alternate cell. This can be assigned for different path stacks, outlines, or pin placement. There is no any limitation for amount of alternate cells. So there are 2 rules. Cells should have same amount of pins, and cells must have the same pin numbers. Part properties, as I said, can be added in parametric database or search and part editor search. And all properties should be defined in the property definition editor. Property definition editor. As you can see, there are pretty big pack of already defined system properties, but you can create your own just using the new property button, define it, for example, I don't know, test property. Choose if you want to package it, and define the rules for this property, where it should be attached to symbol pin or to net, and which entry it should be used in. There are also a set of regular expressions or forbidden symbols. A little bit more about primary properties, such as part number, part name, and part label. Secondary properties, they typically stored in parametric database except height and underside space. So part number is vendor part number for device. It acts as an index into part database for expedition layout tool and the packaging utility. This always should be unique. Examples shown on your screen. Part name is generic name, usually associated with symbol. It is a key for device in the part database when symbol doesn't contain a part number itself, and it's usually used for simulation and expedition layout. And part label is short name for a part, just to quickly understand what is it, what is it doing, just human readable, human understandable. There are no there is no limitation for part labeling in your central library. When you creating PDB, and this is basically what you're doing when you mapping symbol and cell, starting from VX 2.10, there are a bunch of new options. First of them is duplicate pin number checking. This is very useful, especially when we are talking about FPGA or big IC symbol creation. You can reach it using menu output report all pin errors or pin errors for selected. It checks duplicate pin numbers in existing PDB assignments and can check user-defined pin number during the symbol import. There are three options: no check, warn, or prevent. You can also assign power or ground pin type during the symbol import. It was added in 2.8, and if this option checked on, process will assign power ground pin types to the same gate as logic pins, not in the separate tab as I showed you before, but in the same. If it's unchecked, it will just create gates for each power gain Gen D pin type back in times. It was like this. This is why you should have fractured symbols. This is AMD Opteron 2600 and it consists of 6 symbols, but each of these symbols is pretty big, as you can see. Tell me if you want a separate webinar for creating fractured symbols and different types of these fractured symbols, such as homogeneous or heterogeneous. It's like general my request. If you want to see some webinar on specific topics, please write me. My email will be shown in the end of this presentation, and I will try to do something useful for you. So this is it, FPGA. How PDB working with packager. Packager in most basic options that shown in screen. There are no options for update PDB properties, blah blah blah. There is only extract missing library data. Packager in this configuration will be looking at your project and searching for symbols. After, it will extract from these symbols the part number property and check if local parts PDB in integration subfolder of your project exist. If specific parts doesn't exist, or this file doesn't exist in integration subfolder of your project, packager will go to look into central library. In central library, it's gonna use part number to find PDBs for the specific parts that it's needed. If it is initial packaging, so there is no information about all symbols, it will take information about all of them. And then packager will take all these PDBs and build or add to local parts PDB file. Then it's going to run the packager process to make sure that all symbols have valid revdes and valid pin numbers. So that's how you will understand that everything is packaged. If you updated the component into central library and you want to update the symbol, so you need to take this information from central library and put in local PDB. Sometimes you can find the project lib, so-called. It will happen if you using part quest, where you can directly drag and drop symbols into project. And short session of frequently asked questions. Alright guys, if you have any questions, you can write them into chat or raise hand and I will answer your questions. I will take in consideration any feedback. If you want to know something, if you want to see something, just write email to me and I will try to put this information to next webinar. Thank you guys. See you in a month, I think, or maybe earlier. It will be another interesting webinar. Görüşürüz. İyi günler.